our last graph is going to be to graph the function y is equal to the tangent of x, and this one's going to be very, very, very different from cosine and sine. So to do that, we want to set a t-chart up and start to create our values. I'm actually going to do a horizontal t-chart with x and tangent of x, and we're going to start with 0. So the tangent of 0, 0 is right here, has an order pair of 1, 0 with a radius of 1, and the tangent of 0 is, remember, tangent is defined as y over x. So if tangent is y over x, this is going to be 0. Then we're going to do pi over 4. So I'm going to graph that one, or sketch this one. The tangent of pi over 4 is a 45-degree angle in quadrant 1, where the y is 1 and the x is 1. Pi over 4 is a tangent of 1. Then we're going to graph the tangent of pi over 2. Pi over 2 is up. That has an order pair of 0, 1 with a radius of 1, but we don't really care what the radius is because tangent is defined as y over x. That's 1 over 0, which is undefined. Then I'm going to do 3 pi over 4. 3 pi over 4 is a left. It's a 45-degree angle in quadrant 2, so my x is -1 and my y is 1, and the ratio is -1. And then we go to pi, which is pi's left, and that is going to be -1, 0. Y over x is 0. So this is one cycle of tangent where I've gone from 0 to 1 to undefined to -1 to 0. I'm going to continue this on for one more cycle to show you how this works. So we've got pi, which is 0. I'm going to do 5 pi over 4, which is a 45-degree angle in quadrant 3. That's -1. Then 3 pi over 2, which is down. Down is divided by 0 as well, so that's undefined. Then I'm going to go this direction. Oh, sorry, 5 pi over 4 was 1, not -1. I want to show that to you now that I've made that mistake. If I go left 1 and down 1, I have a -1 to -1 ratio. So the tangent of 5 pi over 4 is 1. 3 pi over 2 is undefined. 7 pi over 4, which is this angle here, is over 1 down 1. So that is a tangent value of -1. And then finally back to 2 pi, we get 0. So if I look at 0, 1, undefined, -1, 0, 0, 1, undefined, -1, 0, one cycle is not 2 pi, one cycle is pi for tangent. This is a very big difference between tangent and sine cosine. One cycle is pi for tangent, whereas one cycle is 2 pi for sine or cosine. So I'm going to actually try to graph these values and show you what a graph of tangent looks like. It's very, very different. We're still going to draw a frame box, and I'm still going to talk about my vertical stretch. And my vertical stretch comes from my a value, which if I'm going to graph y equals tangent of x, my a value is 1. My period for tangent is 2 pi, not 2 pi. For tangent, it's pi. The reason it's pi for tangent is because one cycle is pi for tangent. It's much different than sine cosine. So it's pi over b, which in this case is just pi. And the hk value for just this basic graph is 0, 0. So 0, 0. I'm going to put a 1, -1. And I'm going to go horizontally pi units. And I'm going to call this pi. So this is my frame box. That's a single frame of tangent. Now, tangent starts at 0. Let's look at this one right here. Goes to 1. Then the next one is undefined. Undefined, we're going to draw a vertical dashed line because it can never cross that. This is called an asymptote. Then we go to -1, and then back to 0. So the curve is going to look like this. I'm going to put my pencil on 0, 0 and draw it up to the asymptote. Then I'm going to put my pencil on pi and draw it down to the asymptote. And I really can't see this until I draw several more cycles. So I'm going to do a couple on each side. Keep the pattern going. Up, dotted line, down, back, then another one, up, dotted line, and then down, and then back. And I'm going to put the boxes around these frames so that you can see how many frames I'm doing here. There's a frame, and there's a frame. So if I keep the pattern going, it's going to look like this. And same thing. You can draw these each part separately, or you can draw them all at once. I'm going to keep some of these going to the left too. Left is down, then a vertical line, then top, middle, bottom, vertical line. Let's do one more. Top, middle, bottom, vertical line. And once again, I'm going to draw these frame boxes to the left. So this is here. Then I have another one going here. And then I have a half one, but we can continue sketching the whole thing. Comes down like that. I'm going to draw another curve up here and another curve down. So when I step back and look at the whole thing, these are what we call tangent lines. And this is a graph of how tangent looks. And we're not going to do a whole lot with it, but we are going to do some examples where I shift it. So what I'm going to ask for tangent is that you do several cycles of tangent just to get an image of how it looks. You don't have to do that many, but let's do 3 of them. Okay, we're going to graph y is equal to 2 times the tangent of x minus pi over 4. So a value is 2, b value is 1, h is pi over 4, k is 0. So I know that my graph at pi over 4 is 0. That's the left shift that's going to happen. And I'm going to graph a grid. And let's say we also know the period, which is not 2 pi, it's pi over b, which is pi, because it's tangent. Tangent has a period of pi. We can call it a tangent period if you want, just to make sure you have that distinction. So left pi over 4, I'm going to call that negative pi over 4. Or sorry, positive pi over 4. This is a right shift. Positive pi over 4. We're going to go over pi units and call that 5 pi over 4. This is going to be up 2 and down 2. I'm just going to label those there. And I'm going to draw my frame box just like we did before. Now, tangent, halfway between those, is a vertical asymptote. We go up all the way to the top of the frame box, and then we go down to the bottom of the frame box. Sketch one up like that, sketch one down like this. I'm going to draw 2 more, one to the right and one to the left. So this is the one to the right. This is going to continue like this, and this is going to go like that. And then the one to the left, I'm going to go down to the bottom where this one was. Then I'm going to draw a vertical asymptote all the way down. Then I'm going to go up to the 2 and then back down to the baseline. It kind of continues down like that, and this goes up like this. So you can see how this would have been repeated throughout the whole graph and create lots and lots and lots of these. Okay, let's do another example, one that has several shifts. Y equals, we're going to do negative 3 tangent of 2x minus pi plus 1. Okay, so let's set this like we did before. We need to factor the 2 out. 2 times x minus pi over 2 plus 1. Let's pull out our values. I know that a is 3, b is 2, h is pi over 2, and k is 1. So from that, my period is pi over b, so pi over 2. So the period's really tiny. It's pi over 2. And then the HK, ordered pair, that's the middle left of your frame box, is pi over 2, 1. So let's graph, and let's try to set a scale that's going to make sense. If the period is pi over 2, then I maybe want my boxes to be a fourth of that. We're going to make it every eighth. So I'm going to call this pi over 2, and we're going to call this pi, and here is pi over 2, 1, and we'll call that 1, and then I'm going to go up 1 to 4, and then down, or sorry, up 3 boxes to 4, and down 3 boxes to -2 because my A value was 3. And with my A value 3, I want my left of my frame box to reach that high. I'm going to move this pi over 2 here. And this now is the left side of my frame box. I need my frame box to go a period of pi over 2. Well, that's from here to here. So the actual box is going to look like this. And I'm going to draw this as a little baseline so I know where that is. In fact, I'm going to extend that for the length of the entire graph because this is very, very, very crucial for tangent. Something else that I've seen people do, and this is okay, is to extend the length of the top of the box all the way and the bottom. So you know how far you're stretching it happens with tangent. So here we go. We're going to do 2 cycles, and the thing to keep in mind, this is a negative tangent. And as a negative tangent, it goes the opposite direction. Tangent always starts at 0. Let me make this a different color. Starts at 0. And it ends, let's go with orange, ends at its baseline, and halfway between it does a vertical asymptote. That's not going to change, but a negative tangent is going to start down before going up. So then I'm going to draw one from here down to here, and here up to here, and that's a single cycle of tangent. Now, let's do this 2 more times, but let's do both times to the left. I'm going to go back to the baseline, put a line in between, then 4 boxes over, put another baseline point with a vertical asymptote in between. Now, this graph, I keep the pattern going, pops here and then pops here, then here and here, then here and here with yet another one right there. So I could keep this going as long as I want, but then when I sketch them, I'm going to get a sketch that looks like this, and then a sketch that looks like this, and then one like this, and that is a fully stretched out vertically graph of tangent. Okay, I'm going to pause.